Hi, good afternoon or good morning, depending on where you are in the globe. So welcome to the second ZP webinar that we're doing today on the SenseItAll platform. We did one this morning, but we did that one for people in the sort of other half of the globe, but we're doing this for our kind of European and kind of North America, South America colleagues this afternoon. Let me jump straight into it anyway and not waste everyone's time and just come on with it. So what we're talking about this afternoon is SenseItAll. SenseItAll, I've got a strapline here which is going from 0 to MVP in 3 months. So from 0 to minimally viable product in 3 months. I will try and keep an eye on the Q&A tab as well. I haven't yet got around to the I need to basically post in that you can ask questions in the Q&A and I'll try and watch them in real time. But if you have any questions, hopefully put into the Q&A and we can answer the questions there. Don't worry if you're coming in late, or don't worry, don't take notes. This is definitely being recorded and we will send out a recording to anyone who's registered this afternoon. Anyway, so SenseItAll is really about going from nothing to something in a sort of case of 3 months. The background to this is at ZP, we are synonymous with electrochemical sensors. Electrochemical sensors have definitely proven their worth really over 40 years. I mean, the glucose strip was actually maybe say 30 years. The glucose strip is the sort of granddad of electrochemical IVD, in vitro diagnostics, and that's in part why ZP is around. So this is not the focus today, but a lot of inspiration for what we try to do at ZP has come from the glucose strip. Now that has also lent itself quite nicely to the newest sort of technologies for managing diabetics, which is called CGM, continuous glucose monitoring. So if anyone of you can see my camera, you can probably see me, probably hear me rustling. There's been a sort of translation from glucose strip now to these kind of patches. This is an Abbott product. This is the Abbott Freestyle Libre 2. They've made another product, Abbott Freestyle Libre 3, but fundamentally there's the same thing. It's just a little bit smaller. So electrochemistry has proven itself to be both a good product for IVD and a good product for wearable. So let me go forward with what we're talking about here today, which is SenseItAll, but it's only a little note to say that ZP is not a large company. I certainly describe us as a small, medium enterprise. We've been around now for 9 years, and we are ISO 13485. Don't worry, this is not a ZP. Lots of slides on ZP. We are contract developers, contract manufacturers of electrochemical biosensors, and we are primarily in Norway and the UK. That we obviously, like any modern company, we're acting really globally. We do have a large team from all around the world. My colleague Ghana is here this afternoon. So if you can see my mouse, this is Ghana in the front row, myself, and then Ghana is here as well. So Ghana is going to be doing some live demos for you. We're going to end up doing 2 live demos. And that's really important because it'll show you how we can very quickly, just using a QR code, go from one assay to a new assay with just really using a QR code. As I say, we are in Norway, and we have a couple of facilities in Norway, an R&D facility, and also a manufacturing facility. And don't worry if you're joining late, this is recorded. We will be sending out anyone who's registered a copy of the recording. We're also in the UK as well, so I'm talking to you from this office this afternoon. This is an office that we have in Swansea. So in the UK, we've got a couple of sites anyway, so I'll go a bit quicker on that. Now, what's the problem that we have perceived with biosensor development? And I think the problem that we've perceived is if somebody wants to make a new IVD, a new in vitro diagnostic, for example, I'll sort of hold up to my camera, the classic glucose sensor, then the first thing they have to do is kind of develop these electrodes. Now at ZP, we think we've solved that problem. There is a problem in the R&D world with screen printed electrodes. They have the reputation for being kind of low cost, but in fact, when you actually buy them for an R&D purposes, it's the reproducibility or the repeatability of those electrodes that's really a problem, and it really messes up essentially people's it really messes up people's signal. And what I mean by that is, if you're trying to make an assay and you're building upon electrodes, the only variable that you want is maybe the concentration of analyte, but you're confused because in fact you've got two variables. You've got the concentration of analyte, which is the variable that you're trying to kind of develop for, and then you have a variability due to the electrode itself, and it's that variability really confuses people. So there is a problem in biosensor development, and it's fundamentally the electrodes. Now, I'm extremely biased because actually I think we've overcome it. And if you ever come to one of our Julie demos, you'll see that we put a lot of effort into to make sure that the electrodes that we're producing are really reproducible. So I think we've overcome that problem with our sort of SenseItAll stack. For me, this is my opinion, that the most important thing that people of electrochemical sort of sensor technology should be working on is their assay. And that's why I've kind of highlighted this in red this afternoon. That's really where the intellectual property is. People sort of come up with new designs for electrodes and new materials. Yeah, I mean, new materials is interesting, new electrodes is interesting, but it's not really the core IP. I think the assay itself is the core IP. So if you have to spend some effort anywhere, I would work on the assay. Now, underneath that, we have the electronics. So there are many very good companies working in the kind of analog front end part of electronics, and these guys have made some really nice single chip potentiostats. So I say to people, don't build electronics for at least electrochemical sensors. There's plenty of very good chips out there. They've done all the work for you. And I was talking to one company that I do respect in this kind of the potentiostat world, and they were saying, no, we're more focused now on programming or coding rather than actually developing electronics. So the problem with biosensor development used to be the electrodes. I think we've solved that through at least the effort of ZP. The problem with biosensor development is still the assay, but that it should be, because that's where the real intellectual property and the real, let's say, creativity should be. The problem of electronics has certainly gone away. I mean, this is the single purpose biosensor circuit from ZP. There are other companies that do equivalents, and electronics now single chip potentiostats and sort of mini boards holding those chips are available from ZP and other companies. The mechanics are much simpler these days. You're going to see a really improved mechanical design that Gan is going to show you in a bit, where it's really enhanced the user experience. And I also, it's a little comment as well, that what you'll see this afternoon from this Generation 4 SenseItAll platform is little touches like LEDs that help to guide the user to know what the kind of status of the machine is at any one time. One of the problems traditionally in biosensor development is that sometimes the instruments are actually just repurposing of lab instruments, whereas this is a much more, what we'll show this afternoon is much more towards consumer type electronics rather than scientific instruments. The app development, you'll see this afternoon that we can very quickly go between different assays. What we've built is an app that is available on the Play Store, and the app, we can reskin it or rechange the logos very quickly just using a QR code. When we change the QR code, we can change the look of the app, we can change the method file that the app is telling the instrument to do, and we can also change the algorithm that interprets the signal that comes back from the electronics and turns it into information, i.e. concentration. Just checking something. Yeah, okay. No questions at the moment, but I was just doing a quick check. So app development or apps will be covered. Something that we're not going to overemphasize today, but is actually at ZP, we have a platform. We call it SenseItAll. It's a piece of hardware, so it's tangible. We'll put an electrode in there, we'll put a sample on there, and we'll get results in the cloud. And so something that we may be synonymous at ZP for biosensors and maybe electrodes, but really we have a full technology stack, including Julie, which is a cloud system that's been in development at ZP for something like 9 years. You'll get a little look at it this afternoon because the data is actually going to end up in the cloud, but It's much more powerful and comprehensive than what we're just going to show today. And we do have dedicated webinars on this. The next one will be on this, like the 24th of October. So Julie, very powerful. It's really tuned to take electrochemical data. So the SenseItAll platform, if your assay is ampermetric, we can take care of it on the SenseItAll platform. It can go to Julie. If it's potentiometric, same story. If it's voltammetric, same story. Don't care if it's square wave voltammetry, differential pulse voltammetry, square wave voltammetry. You know, we don't. It's very flexible in terms of the hardware and also the fact that Julie can actually receive this. This is almost an existentialist question. You know, why is there a ZP? And really, there is a ZP because, in part, what we perceived was, if somebody wanted to make and I wouldn't suggest that anyone wanted to make a new glucose sensor, but if somebody was, let's say, inclined to make something that was kind of point of need, point of care diagnostics, and they wanted to make something like a glucose strip, once upon a time you would have to kind of find the electrodes, or even have the electrodes kind of custom made. You would have to come up with a formulation. The formulation is still something that you may have to do your own research upon. Then there's the electronics. That was something that you would, you know, have had to have gone off and developed. And certainly, you know, 5 to 10 years ago, this idea of kind of necessarily sending all the data straight away to the cloud was not something that was so much on people's radar. So ZP exists in order to really accelerate the idea of, I want to come up with a rapid test. I happen to want to use electrochemistry. What's my most efficient way of making an MVP, a minimally viable product? Lo and behold, SenseItAll exists. It's only taken us 9 years to get here so far. But efficient means something. It means essentially time and money. And you know, you all know that time and money are really the same thing. You can sell your time for money, or you can buy time of other people for money. But efficiency for us is we can get minimally viable products, and even products much more efficiently, both in time and money, if we're able to bring them onto our SenseItAll platform. Now you'll see this for real in a minute, so don't think of this as videos. And the reason we're going to do it for real is because we have to sort of demonstrate the kind of robustness of this technology. But what you will see in this, what you will see in this video is that we, you know, have a meter. You saw that the person actually scanned the QR code initially. We have electrodes. It's really important to understand how well we make these electrodes and how reproducible these electrodes were. If they weren't as good as they are, the whole SenseItAll platform wouldn't exist. What you'll see Gana do today, she'll make a couple of tests. There'll be no calibration. So many people, when they're developing assays, they have a calibration step, and that's because they actually have a manufacturing reproducibility issue. But you'll see that we don't do that. But the technology stack we have is either it's an electrode or it's a biosensor. We have the hardware, and this is a generation 3 hardware. Today you're going to see a generation 4 hardware. Generation 4 hardware, much more consumer experience. You'll see the app, but you'll see the app changes depending on the QR code that we have. You'll see that the data will go to Julie, and you'll see that we are able to give a result on the phone there and then. So the person gets that kind of point of need rapid result, but beautifully, you also get the raw signal in the cloud. And that's really important for you as a developer, you maybe even as a manufacturer, you as a quality control person. You want to make sure that things are working properly. And it also allows you in the development phase to maybe even apply better algorithms to historical data to see if it can improve your accuracy. So you don't have to ask a question when using the SenseItAll platform, where is my data? It's in the cloud database. The SenseItAll platform can take any of our sensors, the glucose, the oxygen, the lactate, the hydroperoxides, cortisol's in there, androstenone's in there, troponins in there, total antioxidative status is in there, glycerol is in there, urea is in there, uric acid is in there, phosphate, nitrate, potassium. This shows you the kind of, you know, essentially there's about 38 sensors there that can all be brought to the SenseItAll platform. And then the 2 demos we're going to do this afternoon, they're not even in this list. So this is a 40+ analyte, let's say, platform. Mostly today we will talk about IVD. So I will be talking a lot about these screen printed electrodes. I'm holding up a row of them here. And I'm not going to over talk about it because I want to be kind of I want to stay on topic, let's say, but I am wearing also a microneedle array on my wrist here. This is something that we've been working on at ZP for about 5 years, and it's something that's kind of covered by 70 patents that ZP holds. So today I am going to stay very on topic and talk about IVD, but I also don't want to kind of restrict people's thinking to thinking, oh, well, this electrochemistry and these kind of platforms are only good for spot testing. Sorry about the rustling. We can also use it with, this is the microneedle array. This is the watch that can receive it. We can also use it with these kind of technologies as well to make wearable sensors. Anyway, that's a sort of slight digression, and I'll come back onto the topic. Just to say as a warning that even though we have these sensors, people always think, oh, well, you know, your sensor in my application, what's your accuracy? For every application, for example, if we measure glucose in sweat, that's one kind of algorithm. If we measure glucose in interstitial fluid, that's another kind of algorithm. If we measure glucose in blood, that's another kind of algorithm. So when you ask the question, what is your accuracy? Our accuracy is really based on what is your application. So it's a hard question. So yes, we do have a urea sensor and a uric acid sensor and a potassium sensor, but how their accuracy is depends on the total system that we're building into. Except just know one thing, the underlying accuracy of our manufacturing is really quite good. So applications that we're playing the SenseItAll platform into are food testing. We've done nitrate monitoring in soil. So I will digress slightly and talk about implantable sensors for monitoring the stress in fish. And we're also playing in horticulture. Wearables is very big with us. And of course, we do a lot of tests in urine, blood, saliva, even tear film, and on the breath as well. Slight side note, the only reason I bring this side note is I don't want to be categorized as the kind of IVD only company. This is the electronics that we're going to use in the SenseItAll platform that you will see demonstrated in real time as well are also implanted. This is the package. We have a sensor. We have the electronics, and this whole package is actually implanted into fish. This fish is not dead. This fish is anesthetized, and it actually gets implanted into the fish, and the fish is sutured or stitched back up, and the sensors are left in place. So if I could just advertise electrochemistry for a second and say it's a really robust science that, you know, if you've got a couple of fish in a salmon farm and you really care about those fish, you can monitor their health. Obviously, this is a serious application because, for example, one of the biggest industries in Scotland and the second biggest industry in Norway happens to be salmon farming. How do you monitor the stress in those? Well, you make cortisol sensors and glucose sensors, which happen to be electrochemical because we make them, and we put the entire package into the fish, and those fish are then monitored to understand their state of health, the state of stress. But I am going to talk about the SenseItAll platform. I will, you'll actually get to see this in real time in a little bit. But the only reason I sort of bring these two videos up is to kind of say, it is one piece of hardware, but because that piece of hardware, just using a QR code tells the app what to do. The app makes a Bluetooth connection with the hardware. The hardware then runs a method file that was told to run by the QR code. It gets the raw signal back to the app, which then runs an algorithm that it was also told to do by the QR code. So in this case, it can either be used for measuring chilies or ginger. So, you know, you don't always have to pick the most, I want to say, sort of regulatory difficult applications to go after. You know, it's testing things in saliva, blood, and trying to predict human health or control human health is one thing. Working in the food quality industry is another thing. And so we've been, you know, busy playing and developing our technologies in those applications. But also, I mean, super important, the same hardware, different engineer, but same hardware. We're also using it to measure nitrates in water. And because we can do nitrates, and I showed you that kind of at least 38 sensors, phosphate and potassium are also in there as well. So if anyone's interested in agriculture, you will know NPK, nitrate, phosphate, potassium. These are really important analytes for measuring either in water or related to agriculture, because these are key nutrients. These apps look, have a different color scheme, and the only thing that's made these apps appear differently is that QR code as well. So this is a real, let's say, platform. People talk about platform, but literally this one is a platform that we can run all these tests. It says something about, the science of electrochemistry. It says something about the power of the electronics, and we're very grateful for those electronics. And it says something about the power of our ability to convert real world problems onto these kind of platforms. And this is what we do as a kind of contract development and contract manufacturing. Very different form factor, but it is part of the SenseItAll platform. During SARS-CoV-2, it's a different form factor because we're actually collecting exhales breath here. And we were again using screen printed electrodes that were being functionalized to make them specific to SARS-CoV-2. And in this application, we were actually collecting the breath and in real time able to determine whether somebody had SARS or COVID-19 rather, essentially in real time by just doing a quick screening. So very different looking. This is CE mark. So ZP is an ISO 13485 business, and we were able to do that really quite quickly. Why? Because of this SenseItAll platform. We have everything in place. So what I'm going to do now is I'm going to stop sharing my screen, and I'm going to turn off my camera and also mute myself. But my colleague Guyana is going to come online because we promised essentially live demonstrations. So Guyana, are you there? And at the moment she is.
Yeah. Hi everyone, I'm Guyana. I'm an engineer here in Zimmer & Peacock. I'll demonstrate our SenseItAll platform today. So here I have the SenseItAll device, which is the new generation. And I have some ginger sensors and I have some chili sensors. I also prepared some solutions to be tested. I have ginger shot solution mixed with a buffer with 1:10 ratio, and chili sauce chili sauce mixed with a buffer solution again with 1:10 ratio. I also have the Android phone, and I have 2 QR codes which I will use to scan and set up the mobile app. So we can start already. I'll just connect the device using USB-C cable. Right now it's connected to my laptop.
But it's not essential to be to the laptop. That's just your source of power, isn't it?
Yeah, that's just for powering. I'll press 2 seconds and we'll see the light. And we will also see the blue LEDs blinking, which means that the device is ready to be connected via Bluetooth. Yeah, I'll just scan the QR code. I'll run the chili one first. Okay. So now the QR code is scanned, and the app shows that chili sensor is going to be used. Now we can connect to the device. I'll just click this button and then it will start searching all available devices. Sometimes it takes a couple of seconds. Yeah, found. I'll just click on it and then connect to the device. The next that I will do, I'll just click to test settings. I'll change the sample ID. I'll just write chili test 2, for example, and then for the cluster name, I'll just write demo. So these settings are going to go to Julie, and we'll see a demo as a cluster name and the report name as a chili test number 2. Can go back and then press go to save. Now the device will tell us what to do. The first thing that we need to do is to choose the dilution factor. I'll just choose 10 because my solution is 1:10. Then I'll just place the chili sensor with the cartridge. So how it works, you just place it inside and click it up, and now it's connected. And I will pipette 50 microliter of chili solution. And I'll try to cover all the electrodes. Now I can start the measurement by clicking the button. The measurement will take approximately 30 seconds. All the device does during this time, it runs the cyclic voltammetry and sends the raw data back to the mobile app, and the mobile app sends it to Julie, where the data is analyzed. And once everything is done, it sends the results back to the mobile app, and we'll see in a couple of minutes in the results screen. Yeah, so the measurement is done and it gives us 2,900 SHUs. Now I'll just click done here and then show you how the data looks in Julie. I just need to refresh. I'm having some connection issues today. Yeah, Julie test too. I'll just click on it. And here is our raw data. And you'll see some values here after analyzing and some final results. Now I'll just go back, yes, and scan the next QR code so we can run the Ginger application too. And as you see, the phone already recognized the QR code and it set up the mobile app to run the Ginger sensor. The colors and also the text is changed. Now I'll just go here and change the test settings. I'll just call it Ginger test 2 and go to save. Take one of the sensors, lock the device, and choose the dilution factor. But again, when it's like 1 to 10, I'll just click to 10 and pipette 15 microliter of ginger solution. Yeah, it seems like it's ready. I'll just press start measurement. And again, it's the same procedure. It runs the measurement, sends the data to mobile app sends to the cloud, and where it will get analyzed and send the results back. During this time, the device blinks by white color, which means that the measurement is running. And once the measurement is done, when it was successful, it shows green LED. It indicates green, and if not, it's an amber color. So it says the upload completed. I'll just discard this one too and show you the LEDs. I can click done and show the Julie one more time. You see the report and see the results here. Everything seems correct. I think that was it, Martin.
Yeah, perfect. Right. Well, Gan, I appreciate that because I noticed that I was speaking for 22 minutes and you did those 2 tests. You connected to the device, you used the QR code system twice, you did 2 tests and you got the results to Julie. and he did all that within basically about 6 minutes. So that's the real power of not of let's say of ZP, but actually I would say of electrochemistry as a science, which we're we're really lucky to be able to leverage that. But if I was to sort of summarize this, you could see that what we've done now with our sort of generation 4 SenseItAll, and I say we, it's the royal we, it's the the team. They've really put a thought into not screen printed electrodes that you have to stick in some sort of slot. Actually no, they've put a a nice kind of closing mechanism on there. They've made the electrodes sort of more handleable. They put color into there. That's much more of a kind of thinking about how does the user know that that assay is running? How do they know everything's good? Well, the LEDs are kind of indicative of that. So that's when I was making that comment. This is definitely moving away from looking like scientific instruments or repurposing a scientific instrument to actually something that you could, for example, if somebody wanted to do pool water quality control, that was their product idea. So the whole idea of SenseItAll really is to be a kind of OEM solution to people who really want to go to market and do it extremely quickly and not have to build these entire technology stacks. So SenseItAll, what's the purpose of SenseItAll? It's to really accelerate people's success, get there, and we have done this with people from engaging with us at Christmas time to doing demos for their investors in 3 months, because all the technology is there. It's just the only question is what's the target, what's the assay? As a background thing, I don't want you to think of ZP as just this IVD company and SenseItAll is just an IVD product. As I say, I was kind of showing these wearable watches earlier on. These are electrochemical, essentially, devices as well, and they're using microneedles to monitor interstitial fluid, and glucose would be the kind of classic for that. It's a true platform. People use the word platform rather liberally, but we today have talked about, we have 38 sensors that we can bring to the platform, and I didn't even talk about capsaicin and gingerol, which was what Guyana was demonstrating today. And so I think, in summary, SenseItAll is this idea that you didn't have to go away and make bespoke electrodes. You didn't have to go away and necessarily make bespoke electronics. In fact, once we all understand what the assay is, we can just very quickly release it onto the product. I'll just check any Q&As. No, but if you've got any questions or Zim Peacock, don't hesitate to reach out to us. We're kind of happy to engage with people. But if you do have any questions, somebody did ask, where can I get a video of today's demo? It's definitely been recorded. Once this is ended, Microsoft processes it for a bit. As soon as it's ready, I'm going to email you all separately a link to this so that you can watch it and share it with colleagues later on. So the quick answer is no need to take notes, no need to remember exactly what was said, but there will definitely be a video out in a short while. So that was 33 minutes, and in that time, I talked too much. Guyana was super efficient, and you can see, really how robust that platform is, that we could actually do everything we said we would wanted to do, change assay, do quick assays, get the data to the cloud, show it on the phone, etc. So in the meantime, thank you for the question, but I will send you a video by email, and if anyone else has any questions, when those emails come through, feel free to respond. They'll come from me. Okay, special thanks to Guyana. Appreciate it's a little later in Norway at the moment, and from the UK. Have a good rest of the day, guys. Okay, thanks so very much.